Hello students, today we shall discuss the chemical reactions and equations of class 10 science. So I have taken an example of a chemical equation. See, chemical reaction takes place everywhere and we know that. But when a reaction, by looking at the chemical equation, we can understand a chemical reaction. How does the reaction takes place? So what is a chemical equation? Let's first understand. I have taken an example from your book, textbook. Is a magnesium plus oxygen equal to magnesium oxide. That example you will get in your textbook. See this example. So equation means what? You have already done in your mathematics that equation has the two parts, that is left hand side and right hand side. Similarly, this is also an equation. It has also left hand side and the right hand side. So in mathematics we have learned that the both left hand side and right hand side of the equation must be equal, otherwise it won't be an equation. So in chemical equation it also same, the case is same. The left hand side and right hand side must be same, otherwise it won't be equation. So in this way we can represent an equation. So I have written magnesium plus oxygen equal to magnesium oxide. Now in the left hand side, what are the substances in the left hand side? We call it reactants, and the substances in the right hand side are called products. These substance reacts to form a new substance, and this is that we call the product of the reaction. Okay. So this is how you can represent a chemical equation. Now by looking at this equation you can understand that magnesium and oxygen reaction between magnesium and oxygen takes place and the product become the magnesium oxide. Alright. So these are reactants and these are products. Now products may be more than one. Here only there is a single product. Okay. Now how to write a chemical equation? See, we have already learned a symbol in class 9. We have you have learned already the symbols for the elements and the molecules. So you can use the symbol in order to write the chemical equation. First, magnesium. What is the symbol for this magnesium? Is Mg. You know this. And what is the? These are the oxygen molecule. I mean oxygen gas. So this molecular symbol is O2. Mg plus O2. And this is magnesium oxide. This is a molecular symbol. What is the molecular symbol of magnesium oxide? MgO. Now see, these we have symbolized. While looking at this equation we can understand the reaction. Okay. Now this type of reaction is called the skeletal chemical equation. Skeletal chemical equation. You will get in the book if you go through this word. Go through the textbook. You will get this word. Anyway, now these are the these skeletal equations we need to balance. If we don't balance, unless it is balanced, these are called skeletal equations. If we balance these chemical equations, then those will be called balanced chemical equations. Now what is the balanced chemical equations? Balanced chemical equation means the number of number of atoms in the right hand side, left hand side and right hand side must be equal, or the mass of the products and reactants must be equal, because in class 9 you have already got the mass can neither be created nor be destroyed in a chemical reaction. So that is, the total mass of the element present in a product is a chemical in a chemical reaction of a chemical reaction has to be equal to the total mass of the element present in the reactant. That means total mass in the reactant side must be equal to the total mass of the product side. So from this concept we need to balance this. That is, the balances is nothing but we have to equalize the number of atoms in both sides. This is the balancing of the chemical equations. Okay. Now how to balance, we can understand this. See, let's take an example. We can balance this equation also. So see, it is not balanced. This is the one element of magnesium here, in the left LHS. In RHS also one element, but oxygen there is only one atom, and here there are two atoms of oxygen. So these are not balanced. So how can we balance? We must add, and remember, we must add number to the prefix of the molecule or element, not in the suffix. See, this 2 is in the suffix and we cannot touch the suffix. We can just add the numbers, put the numbers in the prefix. So I have put 2 in order to equalize the oxygen. See, there are 2 atoms of oxygen in the LHS, and when I put 2, there will be 2 atoms of oxygen in the RHS also. So oxygen is balanced, but magnesium is not balanced. See, here there is only one magnesium, there are 2 magnesium, so we have to again equalize the magnesium. So in order to balance this, we need to put 2 mg. Now you see, this equation is balanced chemical equation. See, there are 2 magnesium, oxygen 2 and oxygen 2. Atoms are equal in LHS and RHS. So this is the balanced chemical equation. Let me show another example. Fe plus H2O equal to Fe3O4 plus H2. See, this is also a skeletal chemical equation. So we need to balance. This is not balanced. See, if iron atom is 1 and there are 3 atoms of iron. There are 2 atoms of hydrogen. There are 2 atoms of hydrogen. This is balanced. But in case of oxygen, there is only 1 atom, and there are 4 atoms of oxygen. So we need to balance this. So how can we balance it? Fe3 is there in the suffix, 3 atoms of iron. So we must put 3 in the prefix of the iron atom. So see, iron is balanced. And what about oxygen? There are 4 atoms of oxygen. So what can we do? We can put the 4 in the prefix of the H2O, I mean water molecule. So there will be 4 atoms of oxygen and 4 atoms of oxygen in both the sides, LHS and RHS. Now hydrogen, if we check the hydrogen, when I put the 4, if we multiply the prefix and suffix to be multiplied, because there are 4 atoms of H2, so 4 to the 8 atoms, total 8 atoms of hydrogen in the left hand side, and in the right hand side there are only 2 atoms of hydrogen. So we need to balance this hydrogen. How can we balance it? We need to put 4 in the prefix of the hydrogen molecule. Now you see, all the elements are balanced. See, Fe3, 4 oxygen, 4 to the 8 hydrogen, 4 to the 8 hydrogen. So this way we can balance the chemical equation. When you balance this, these are the balanced chemical equations. So next you see, we see the types of chemical reactions. What are the types of chemical reactions? We can understand this. First one is combination reaction. Types of chemical reactions. So number 1 is combination reaction. So what is the combination reaction? Combination means combines. In the reactant size, 2 or more products will combine to form a new substance. So there is an example in your book, I can mention it. CaO plus H2O equal to CaOH twice. So we can mention the physical state. These are the physical states of the molecules. Calcium oxide, S means solid, H2 means water in the liquid form, L means liquid form, and calcium hydroxide, that is slacked lime, in the aqueous form. Okay. Now this is the example of a combination reaction. See, there are two reactants combined to form a new substance, a new single substance. So these are the mainly type of combination reactions. Two or more substances combines to form a new substance. There are many more examples in your book. You can see the other examples. Next, decomposition reaction. See, decomposition reaction, we can take a example CaCO3. When it is heated, it is broken into calcium oxide plus carbon dioxide. These are the physical, if I mention the physical state, this is solid, and this is gaseous. G means gaseous. So this is calcium carbonate or limestone. When limestone is heated, it is broken into two products. Calcium oxide is quicklime and carbon dioxide. I have mentioned the physical states also. Now, what is decomposition? See, a single product here. A single product is broken down. How it is broken down? By applying heat. We are applying heat. It is broken down into two or more products. If two or more products, those will be the decomposition reaction.